everyone. This is lesson 3.5a, solving cubic equations by factoring and graphing. And we have 3 learning targets for this lesson. We can explain how solutions of equations and zeros of functions are related. You can solve cubic equations, or you can write a polynomial function given information about the zeros. Okay, so let's grab a highlighter and talk about where we're going to find the solutions of our cubic equations. So if you already have a solution that is graphed, what you can do is figure out where that graph intersects the y-axis. So I've got 3 different situations right here. We've got one solution. So if you wanted to mark where it crosses, and it looks like it kind of hits it in lots of places, but I promise you it only hits in the one spot right there above the 2. So you can see that you have a solution here where x is equal to 2. Let's highlight that solution. Okay, second one over here, I have 3 solutions. So the most that you can have with a cubic function is 3. 1, 2, 3. And if you remember, cubic is going to be x to the 3rd power. So if you're taking a test and it has more than 3 options for solutions, you know that that's not going to be the answer. So I have 3 solutions here at -2, 0, and +1. Let's highlight those. Okay, or we can have 2 solutions. So I've got a solution here. Notice how it kind of like bounces off right here, or it reflects on the x-axis, and then this one goes through. So this is reflected or bounce. I actually like to use the word bounce. Just like a ball hitting like a wall or the floor, it's going to hit it and then bounce back in the other direction. And then this one goes through. We're going to talk about that in a minute. Now, what you have is a situation, if it goes through, it's only going to be there one time. So that is the actual +2 right here. But on this one, see how it's bounced? That is called a repeated. So I need you to highlight repeated. And when I mean repeated, most of the time it's there twice. So 2 times. And I'll show you how that works in a second as well. So in general, if you already have a graph and you're looking for the zeros of any function, it's always going to be on the x-intercept, assuming that it's not part of a system. So notice that it is different from a quadratic function. So a quadratic function can possibly have no solutions at all because it doesn't intersect the x-axis. But a cubic function will always. So your only options are 1, 2, or 3 solutions. So I'm going to give you the opportunity to answer this first question here. It says, what are the solutions of the function? First of all, we need to try to figure out how many solutions it has. So you can kind of see right now that it crosses at 0, it crosses at +1, and it crosses at +2. So it has 3 solutions, and those solutions are 0, 1, and 2. And notice how the graph goes through the x-axis, and they're not going to be repeated. So what happens if it is not graphed for you? Now you got to remember the rules when you're graphing on Desmos. You want to make sure that it is y equal or f of x equal to. You can't graph it when it's 0 equal. So be really careful with that. This is already in the perfect form. So I'm going to go ahead and pause the video. I'm going to type it into Desmos, and then we're going to sketch the graph. Okay, just do a quick double check and make sure that you have the green banner at the top. You're using the Desmos Tennessee version. So I've got mine already typed in. As you can see, it's got this kind of generic up roller coaster type shape. You can tell that it has bounced off the x-axis here at -4, and it has intersected also at 0. So I'm going to do a quick little sketch here. Oop. Not my best, but I'm going to put a dot here, and I'm going to put a dot here. So remember, it's only when your x is equal, or your it's on your x-axis, which is here. So this is going to be -4, and 0. Now, I do want to point out, though, in case they ask, this one right here that has bounced, this is a repeated solution. So typically what that means is that your x is equal to -4 is there twice. So if you were going to maybe go backwards and you see the graph and it asks you to write a function, then you would use x equals -4 2 times and then x equals 0 1 time. But we can only see 2 solutions. Okay, so this next example is very important because it is not ready for us to type it into Desmos. What you're going to need to do is make it equal to 0 and then change the 0 to y or f of x. So I'm going to subtract 1. There is absolutely no need to simplify this because you're using Desmos. So make sure just change that to either y or f of x. And this is what I'm going to type into my technology. Okay, so I have it typed into Desmos. Everything pops up. This one looks like it's going to have just that one solution. I have a little y-intercept down here, but that's not a solution. So my solution is going to hit right there at 3. So let's do a little sketch. Right there. X is equal to 3. So on this last one right here, I want you to look at it. I want you to write down the solutions, and I want you to consider whether or not they are going through or if they are bouncing off the x-axis, whether or not they're repeated. So pause the video, write those solutions down, and then unpause, and we'll check your answer. Okay, so it looks like we've got a solution here that is at -3. We have a solution at 0, and we have a solution at 1. So I have 3. None of them are repeated. And that's as easy as it gets. So next up is factoring, and I know it's not your favorite part, but if you can tell that your function is already factored, all you have to do is simply set each factor equal to 0. And you don't even really have to factor. You just have to learn how to use factors. So I'm going to take my highlighters and highlight each factor. Now, make a mental note here. See how that's squared? It means that this is there twice. So I have x minus 2. I have x plus 3. And then I have an additional x plus 3. So what's going to happen is this yellow one is going to give me one solution. So remember, your solutions will change signs. So if your factor is x minus 2, your solution is going to be positive 2. But when we do these, it's going to give me the same solution. That is a repeated solution. So if I was to guess at what your graph looked like, it would go through positive 2, and it would bounce or reflect off of the -3. And since the front part of this is positive, that means it's going to have this up coaster pattern. So there's lots of things that we can do with this. Not yet, but that's basically how you use your factors to find solutions. So on example number 2, it is not factored, so we are going to need to do the process of factoring. Do a quick greatest common factor check. Nothing is in common with all 4 of these terms. So if I have 4 terms, I can simply just start with a 2x2 box and plug in. Remember, this is our first term, our last term, and then these 2 go wherever you want them to be. Don't forget your negative on here. And then just look for the greatest common factors, okay? So I'm going to do columns because that's what I always do. So I have an x squared in common here, and I have a -16. And I'm using a negative because the top number is negative. And then that means if I work backwards over here, I'm going to put an x, and this is going to wind up being -2. Yes, just do a little quick check here. So temporarily, I have an x minus 2, and I have an x squared minus 16. Now here is where factoring completely is different from solving. So as long as you get to this point, you can solve it perfectly fine without factoring it completely. Those of you with a keen mathematical eye can tell that this is a difference of squares. Absolutely, you can factor this again. I'm going to show you how to do it without factoring it twice, just to prove to you that it doesn't have to be factored completely to solve it. But if you do solve this without factoring it, make sure that you remember if this is squared, you're going to get 2 answers from this. So when you take the square root of both sides, a lot of people do forget this, you get a positive and a negative 4. So that's 2 different solutions. This one, on the other hand, when you add 2 to both sides, you get a positive 2. So there's all 3 of your solutions. Okay, so here's our last factoring example, and we need to talk about this. First of all, to be able to factor, your equation needs to be equal to 0. It is not equal to 0. And number 2, there's something that's very tempting to a lot of new math students. What they want to do is they want to divide both sides by W. Please do not do this. If you are listening to this video, please do not write this down because I'm going to erase it. What happens is when you divide by a variable, that variable is undefined. It could be any number. And if it could be any number, that means that your variable could be equal to 0. And that's a big no-no in math. You cannot divide by 0. It is impossible to do so. So you're not allowed to do that. So I'm just going to go ahead and erase it. Okay, that's very important that you know. And I'm going to go ahead and subtract this to make it equal to 0 because that is what it should be equal to anyway. So I have 5w cubed minus 50w, and then we're going to take a greatest common factor here. Looks like I've got a 5 and a w in common between both of them. And then I'm going to write my leftovers, so it'll be w squared minus 10. Okay, now that looks like this could be a difference of squares. It is not, because 10 is not a square. So we are done factoring, but remember, factors are not solutions. So we have to set our GCF equal to 0. GCFs are always going to be equal to 0. And then this one right here, remember, if it's squared, you're going to get 2 different answers. So w squared equals positive 10. And listen, if you can't take the square root of this number, leave it. So I'm going to put a positive and a negative square root of 10. Of course, try to simplify it using your calculator, but you can absolutely use that as a radical, and that's fine. So you have 3 different solutions for this last example. Okay, so in this next section, we are going to go backwards. Instead of us having a function that we need to solve, we are going to be giving zeros, aka solution. So our solutions are -2, 3, and 6. So I'm going to immediately write them down as solutions. Like that, okay? So what I want to do is go backwards. So from the solution, I'm going to create a factor. So we all know that the solutions of the factors have opposite signs. So this factor is going to be x plus 2. So these are the factors, x minus 3, and then x minus 6, okay? And these factors all have to be equal to 0. Now, you can absolutely leave it like this if you want to. It's perfectly fine for me. I love this, but what they really want you to do is go a step further, and they want you to multiply these 2 together, and then that answer needs to be multiplied times x minus 6. But honestly, for your notes purposes, I just want you to do this. So if you are an honor student, then I would go ahead and multiply those together and just see what you get. You can also write it as y equals, or you can write it as f of x equals as well. All right, so over here, same. I'm going to immediately say x is equal to -4, x equals -2, and x is equal to 5. And then I'm going to change them into factors. Like that. Set it equal to 0, or y, or f of x. And then what you would do is you would multiply these all together. So what I'm going to do is going to go over to the side. I'm going to work these out. And then I'm going to write down what I would get if they are properly multiplied together. Okay, so if you decided to go ahead and multiply them out, this is your final result here. And let me show you really quickly how you can check this answer using Desmos. So this one, you have solutions at -2, 3, and 6. Click back over here. All right, this first one right here, -2, 3, and 6. Now, Desmos will check your answer for you. It will not find the equation for you. This is something that you're going to have to do on your own. Now, let me hide this one and show you the second one. See how the solutions are at -4, -2, and 5, which is exactly where they were supposed to be right here. Okay, so I'm just going to warn you, this last one right here is a really good, but it is a difficult question. So just bear with me. Hopefully your end of course isn't going to have anything this difficult on it, but the setup is, it's not too bad. Okay, I promise. Just bear with me, okay? All right, so this problem in a nutshell, what they're trying to do is they're trying to get us to figure out what are the dimensions, what is the value of x, if this basin can hold 36 cubic feet of water. Okay, so 36 cubic feet that's volume. So what I'm gonna do is immediately think, what is the formula for the volume of a rectangular prism? So it's gonna be length times width times height. So here's the kicker though. Here's what makes it super hard. A lot of students are just going to say 2x times x times x. This is incorrect. So if you read the question, what it tells you is that it's got like this little thickness around the sides. So it's like the walls are 1 foot thick. And so is the floor, the bottom of that shape. So what you're going to have to do, you're going to have to realize that this is 2x from here to here, but then you also have 1 foot on either side of like wall. That wall does not hold water. What you're trying to do is you're trying to figure out all of this part right here. So the water is going to go here. So that means that we only have room for water when you have 2x, but then you have to take away the width of each wall on the two sides. So that's going to be -2. So now I'm going to do the different side over here, which is x. Now x also has a wall of 1 foot on either side. So the next one is going to be x minus 2. Be proud of yourself, okay? Next up though, this one does not have a top. So just the bottom section here is 1. So that means that our third dimension, our height, is going to be x minus 1. Once you realize that, everything else is very easily solvable, especially if we're using technology, and we are. So the next thing you need to do is make the connection that 36 is going to be your volume. So you're going to do 36 equals, and then these are your dimensions. Okay. Are you able to type this in using Desmos? We are not yet. Okay. Remember, you have to subtract this 36 because you want it to be equal to y or f of x. Okay, so I'm just going to change that to y, and let's go ahead and type this into Desmos, and let's see what happens. Okay, I have typed this into Desmos, and this is kind of what it looks like. If you zoom out a lot, you can kind of see, oh, it's got that up coaster pattern to it, but it's going to hit right here at +4. +4, that's going to be your solution. The reason why this is an appropriate solution is because it is positive. A lot of times when they do word problems, especially quadratic word problems, you're going to have a positive or a negative solution. The negative is always going to get kicked out. And the reason why the negative gets kicked out is because these are lengths. They are dimensions, and a dimension cannot be negative. So this is a positive answer. This is great. If you wanted to check it, assuming that your function was correct, though, you can plug it back into your function and make sure that it works. But that's all we're going to do for this lesson. And as always, just let me know if you have any questions.